maintain the pressure inside at 300 kilopascal when the volume is zero. When there's no volume in the cylinder here, the spring here actually very you know, right, the spring has a pressure of 300, the piston, because the spring force pushing down the piston, and we have 300 when the volume is zero. And then when and 3000 kilopascal when the volume is 5 cubic meters. Because when the pressure in the cylinder here increases to this pressure increase become 5 cubic meters, shown there, 5 cubic meters here. The pressure here experienced by the spring here is actually 3000 kilopascal. So that is what I'm trying to say. The device is because the spring will be compressed at that time, right? So when the piston moves up, spring will compress, so more pressure, more force on the spring. And of course, we still assume that spring is a linear spring. The device is connected to a steam line maintained at 1005 kilopascal and 200. So this line here is at 1005 kilopascal and 200. You can see. So this line, the pressure here, if you open the valve, so the fluid will go inside that. Determine the final temperature and quality if appropriate. Quality here refers to dryness fraction, the X. When the valve is open and steam in the line is allowed to enter the cylinder until the pressure inside matches that in the line. That means until the pressure in the cylinder reaches 1500 kilopascal. Also determine the total work produced during this adiabatic cooling process. So you understand that, right? So we have a piston cylinder here, start with 0. Initially the volume is 0, so it starts with 0. Initially the piston here is actually touching the floor of the cylinder. Then we open the valve, we open the valve, and then this supply line will supply liquid here or steam whatever at 1005 kilopascal and 200 degrees C into this cylinder until the pressure in the cylinder reaches that 1005 kilopascal. That is what the question says. So the first thing we do is we can find out the relationship of the pressure in the cylinder, which is controlled by the spring, with the volume. So basically what we use is linear spring equation, and you are given the two conditions, right? Initially and after the very beginning of the question. So use the two conditions, we find out the relationship between the pressure and the volume. So eventually you end up with this equation here. So now the question is, if I charge that 2005, what will happen, right? So during that process, the pressure in the cylinder will keep increasing. The pressure increase until 1005, and the volume V2 is 2. So we use our energy equations. W out here is due to the movement, and this W out is due to the movement of the cylinder. The cylinder moves, so you have a boundary work out, and then we have steam coming in, flowing in, and then we have work input, work done due to the work output due to the cylinder, the moving piston, and we have all this mass from 0. Initially there's no U1 there because initially it's 0. The volume is 0 means you won't have mass inside. So then we have, so this is M1 U1, that is equal to 0 because initially the piston is start from 0 volume. So then we solve that equation, and the W out you have to perform integration because you filled up this pressure here slowly, right, bit by bit. So you have to, the pressure is not constant, and you have a spring behind also. So of course the pressure is proportional to volume, so you have to perform integration using this equation here. Then after that we get the work done. We substitute it into our energy equation. From energy equation 2, this one, you will get this expression. and we sort of like start there already. So the rest of the step is you have to try and error, right? So you cannot, you have two unknown in one equation, and the other relationship is the internal energy U2 here is related to this here, and these two are related. This one and this one. They are related from the property in the spin table. So if you really have to do that, you have to go and check spin table, try out all the values. So questions like that are difficult to solve manually. So you have to start with there, you start with that. So let's say a question such as this, let's say, I haven't set my question, nothing yet, I just want to say something. A question such as this can also happen during the exam. But the question will tell you that prove or show that statement, something like that, right? So why not? Let's do one, right? Or just stop at that and then show how you can carry on doing it. So you have to try using V2 and then see what you get the V2 and then check the table, see whether they are the same V2 and V2 or not. So very difficult. I think that is my last question here. I think in the former tutorial there's a last question. I add in one here and I will let you look at this. It's quite straightforward but quite interesting question, this one. So I think I will just stop here. The solution is quite straightforward.